Hey guys, welcome back. So today I'm working on this Generac GP7500e. This one actually belongs to Jason. He's a local guy who buys and sells equipment, and he bought this one some time ago under the pretense that it had a good engine and a good power head. It only needed the fuel system cleaned up. So he cleaned it up, and once running he discovered that it didn't make any power. So he brought it to me. I diagnosed it as having a bad power head, and unfortunately at the time I didn't have a suitable power head to put on here. So he took it back, kind of sat in the corner of his shop for quite a while, and then one day he found a GP7500 parts machine. It had a blown engine, but everything else was good, including the power head. So I made a video on that, putting that power head on here, and by the end of that video we had a machine that was running and making power. And unfortunately, when I did the load test, it fell on its face at about 4,500 watts. And this machine is rated at 7,500 continuous. So about half the horsepower was missing from this engine. And what I discovered is that the camshaft is wiped out. Both the intake and the exhaust lobes are ground down. And after taking a look inside with the borescope, I could see that was the least of this engine's problems. Everything was covered with rust, and I would say this engine was underwater at some point. So, although it is possible to fix, it's not really practical. There's just too much damage inside of there. So he took it back, and well, it's been another few months, but today I think I might have a suitable engine to get his up and running again. This is another Generac GP7500 that was given to the channel by Ken of Ken's Small Engine. This was a customer's machine. It stopped running, and he diagnosed it as having a bad camshaft. So I verified that diagnosis and made a video on putting a new camshaft in this engine, and now it is up and running well. So I think the goal today is to get this engine swapped into this generator and hopefully getting it running at the rated 7,500 watts. So let me get this up on the lift. We'll start taking it apart, get the bad engine out. We'll put the good engine in, and then we'll put it to the test. See if we can get 7,500 watts finally out of this machine. So although this engine is junk, a lot of the stuff attached to the engine is actually in very good condition. The engine I'm going to put on here has no airbox, has the wrong carburetor, and the blower housing is rusted quite bad. So I'm going to move all this stuff over to the replacement engine. I'm also going to get the flywheel off. This is something I might save. And eventually I'm going to get the crankshaft, the piston, the connecting rod out and see if any of that can be salvaged. I don't have the right puller to get this flywheel off, so I put the nut back on just at the same level as the crankshaft, and that's going to do two things. First, it's going to help protect the crankshaft, and also when the flywheel pops off, it's not going to end up on the floor. So the idea is you just apply a little bit of leverage, take out the play, and then give it a good hit, and it should pop right off. And there we go. The starter on here is good, so we'll salvage that. And we're also going to reuse the battery. I've already uninstalled that. In order to get the stator off, I actually have to get the exhaust system off first, since it uses the stator as support. So there's just 2 bolts here holding the exhaust on. We'll also remove the bolts for the bracket, the 2 bolts on the head, and the exhaust should slide right out. I was just getting ready to drain the oil, and I noticed something when looking at this engine that I did not notice the first time. If you look at the crankcase and the cover and what's in between, you'll see there is a bunch of RTV. That is not factory. That is a telltale sign that someone has had this open before. And given what I saw looking in at the engine using the borescope, I would say they most likely Frankensteined this thing together at some point, and that's why this engine is not producing the power that it's supposed to. Anyway, let's get the oil out. We'll get the wires disconnected, the power head off, and we'll open up this engine. Take a look at it and see how bad it is. And this chunk's dropping out. Not a good sign. But I guess I kind of knew that because there's a bunch of rust in there. And those pieces that fell out, it's just rust. So while that oil is draining out, we'll just get the wires disconnected. So we're just about ready to get this power head off. We just need to remove the bolts holding it to the rail, as well as the two up above. But I've got to wonder too, the rust that's inside this engine, I don't know the history on this, so I just assumed that this was underwater at some point. Now I'm kind of second guessing myself, because even the engine that I'm going to swap in here, that one had some rust inside as well. And I think that's why that cam failed. And I do know the history on that machine. It belonged to one of Ken's customers. He did store it outdoors, but it was in an enclosure. And once Ken got it, I know it was stored in the basement for about 4 years. So I think some of this is just environmental. Humid air, outdoor, unclimate controlled conditions can definitely lead to condensation inside the engine. And of course, if you don't exercise the engine, that's just going to turn to rust. So, yeah, maybe that's what happened here. Not sure. Maybe we'll get lucky and this will just come right off. Especially since we had it off recently. Hey, there we go. A lot of the bolts were fairly loose and very inconsistent as far as how they were torqued. Yeah, it doesn't look great, but not quite as bad as I imagined either. I mean, the crankshaft obviously has a ton of rust, a ton of pitting. This gear isn't looking a whole lot better. And, just everywhere you look around, you see issues, bits of rust where there shouldn't be. And down in the sump, that's probably the worst of it. This stuff down here, it's kind of the color of mud. And there are chunks of rust mixed in there. So, yeah, not a good thing. You don't want to see that inside of an engine. And as far as this cover goes, there is a well-defined line, like a stain, going across, and that would have been the oil line. I'm not actually seeing any evidence of water. If this had gotten water in it, that line would be higher. The damage would be more severe up above that line. Ball bearings surprisingly aren't totally shot. Anyway, let's get the camshaft out. We'll get the counterbalancer out and the crankshaft and take a closer look at those items. Yeah, not great. You can see the wear right there. The metal's kind of flaking off where it's been wearing. Surprisingly more of a lobe than I thought I'd see, actually, on both of these. But yeah, definitely damaged and pretty sharp. Get the lifters out. Bunch of rust. Same on the bottom. I'm noticing here too, I'm getting a bunch of anti-seize all over my glove. So the tapered shaft has anti-seize on it. And I wouldn't think that would be a good idea. I mean, this is a friction fit. Anti-seize might reduce that ability for the tapered shaft to hold the rotor if you've got something in there that's, granted, not exactly a lubricant, but I would think keeping it dry would be the way to go. So there's the counterbalancer. And more of the same, just rust. Part itself isn't physically damaged. Anyway, let's get the 2 bolts out and get a better look at that crankshaft. Cap doesn't look terrible. So most likely the connecting rod and the piston are reusable. Yeah, main journal, not looking good, and I just made it look worse. The ball bearing, surprisingly, it's not making noise and doesn't have a ton of play. So somehow that survived. We've got another bearing in here, which spins. You can actually feel it, though. It is crunchy, so that one is not in too good a shape. If you look at the counterweights on the crank, they're absolutely littered with chunks of rust. So I would say that was the source of the rust, at least the majority of the rust that did this engine in. There's just a ton of it down here. Even these bolts on the oil sensor have rust on it, and there's more of that mud down here. At least it looks like mud. I'm sure it's just ground up pieces of rust. It's just been powderized and mixed in with everything else. As far as this end on the connecting rod, surprisingly doesn't look terrible. Actually looks reusable. And if I zoom in on the cylinder, you can see also rust on the cylinder walls. So yeah, this engine, definitely done. It has seen quite a bit of moisture. Not great, but not as bad as I thought either. The rust near the top here, I cannot really sense that. So that most likely was already sanded smooth by the rings. It's really not until you get to the bottom where there's a lot of pitting, and you can definitely feel that. The other side also not looking good. I would say it looks worse. Can't really feel it. Not until you get down there. So yeah, the cylinder, it is not in very good condition. The rest of it, though, that just came off, not too bad, actually. The piston, I would say, has fairly normal wear and could be reused on a future project. And the head is also in very good shape. It's actually pretty clean. And same on the combustion side, very little carbon buildup. So yeah, these parts, they would be good potentially for a future project. As far as this block goes, I think this is going to be recycled. If you were desperate, you could definitely rebuild this and get back a lot of the missing horsepower just by honing the cylinder and, most importantly, getting a new camshaft. Of course, that doesn't solve the other issues. I mean, the ball bearings probably should be replaced. This one in particular is very bad. And of course, the crankshaft is not in very good condition either. Thankfully, we don't have to reuse this. We do have another engine that's in better shape. So let's get that one installed. So I'm going to pull the carb off now. This one has the wrong choke mechanism. The carb itself is fine, but with this type of choke, it's expecting an auto choke, which this one's not. So we'll pull this off, and also the blower housing. I want to replace it just because this one's a little rusty, and I need this off anyway because when I put the rotor on, I'm going to use a wrench to hold the crankshaft still on the flywheel nut while torquing the other side down to 30 foot-pounds. So we'll just put the wrench like this and hope that it stays while we torque down on the rotor. So this is the other blower housing I have. It's in pretty much perfect condition. Unfortunately, it won't go onto this engine. And the next move here is to get the blower housing on and pull the engine over just to make sure the rotor is not making contact to the stator. So we're going to have to stick with the original blower housing, which actually isn't in that bad a shape. You know, there is just a bit of rust on the top corner here. You know, not too bad, but, you know, I was hoping to use one that was perfect. Anyway, the fact that this doesn't fit kind of highlights a different issue here. Although this rebuilt engine came from a GP7500, it's not exactly the same submodel. And you can see this head is quite a bit wider than the original engine that was on there. It's actually wider by an inch. And although that doesn't sound like a big deal, it means that this blower housing won't fit, and the nice clean exhaust system that was on here is actually going to be too long by about an inch. So potentially we can get that to work. Otherwise, we might have to use the exhaust that originally came with this engine, which is pretty rusty and crusty. So yeah, hopefully that's not the case, because we're going to have to clean it up if we do use that one. Anyway, let's get the old blower housing on, pull the engine over, and make sure everything spins without issue. Going to get this plate on top of the cylinder while we're here, because one of the bolts that holds the blower housing on also holds this in. And this also applies the tension to the governor spring. So without this, you're not going to have any cooling or any engine speed. I've got the spark plug removed, so there's no compression fighting me. So I'm going to start just by pulling it over slowly, make sure I don't hear any scraping, and that the engine spins freely. And it does. So let's try it fast. And perfect. No scraping, no strange noises. I think we're good. So I think we're safe to start connecting the wires back on the machine. So we're going to start with the engine control side with these white wires. This one actually comes down from the control panel, and there's a charging port. You actually plug it into the wall, and it sends 12 volts down to this post, which then connects over to the battery. So we'll add the battery lead, and we'll bolt that down in a minute. We also have this right here. So we're getting a full-time positive over to the solenoid. So this is actually switched with the ground wire, which goes up to the control panel where the switch is. We also have the low oil switch wire, the yellow one coming out of the engine, going to the low oil module, and that connects in to right here. These two wires go up to the control panel. You can only connect it in one way, otherwise it won't work. And then we have the wire coming down, which goes over to the ignition coil to ground things out when you turn the switch off. Now, I wanted to double check this because when I tested this engine on the other frame, I shut the switch off and the engine didn't shut down. So I was kind of second guessing myself here as to why the engine didn't shut down. So I've got a multimeter set to test continuity. We'll put one of these leads on the ground, and the other one right here, which is the wire coming from the control panel. Now, the switch right now is in the run position. If I click it off, we don't get a beep. So I was kind of second guessing myself as far as what is going on here, and I couldn't find a problem. And then I remembered this one picks up the ground from the high voltage side of things. So now that we're probed over there, if I go back here, and I'm just going to put the switch back to the run position so there should be no ground. Now I'm going to click it off, and we get a ground. So that's why it wouldn't shut down the engine on the other frame, because we didn't have the high voltage side connected. You know, in this case, we will. So the engine should shut down without issue. Yeah, it's interesting. Even with the negative on the battery connected to the body ground, you know, we don't get a crank signal. There's absolutely nothing. So in order for the engine controls to work, you know, we also need this ground wire. So it's just not for killing spark. If I set you kind of right here, and I hold this ground wire anywhere on the body, I can now crank the engine. So that's just something to keep in mind. If you're working on one of these without the high voltage ground, you're not going to have signal to kill spark, and you're not going to have signal to crank either. Now for the exciting part, we get to reconnect all these wires. And I mean, for me, it's actually exciting. You know, I know watching it can be a bit much, so I'll probably fast forward a bit through this. It is important, though, that you do this right, because even though we have circuit breakers, the circuit breakers are up in the control panel. You get something wrong down here, and those circuit breakers may not protect you. Anyway, these are color-coded. Luckily, the colors match. It's not always like that. I did mark it anyway, at least with the whites. You know, we have two whites coming out. Technically, it doesn't matter how we connect it, but I want to get it exactly the same as it was. So we'll start with just putting all these washers on the bottom. Then we got a white, a black, a white, and a red coming from the stator. And we have matching colors here. So we'll do a white, washer, lock washer, and nut. So I kind of just screw this on a bit. We leave it loose until everything's connected. Then we'll kind of situate everything and then tighten everything down. So now for the AVR, there's just a quick connector right here. It only plugs in one way. And we got the two wires going to the brushes. The positive, it's usually red and labeled. That goes on the left. Negative goes on the right. And if you get it backwards, it's not going to cause any damage. But your generator is most likely also not going to power up because the residual magnetism, or in this case, they're small permanent magnets, they have a north and a south pole. And if you reverse these wires, it's going to try to reverse the poles on the field. And it's not going to be able to do that. Most likely it's just going to collapse the field and the generator's not going to power up. It's a very important step here. You want to make sure you zip tie this because these wires are quite long, and if you don't, they can and will get sucked in by the rotor. And when that happens, it's going to destroy everything. So I'm using pretty much the same type of zip tie that was in here. Has a hole for the bolt, and it attaches right there. So we just turn it around, being careful not to situate any wires where they're going to get hung up, and bolt it down. Going to get the uncover on. Usually I leave them off until we get it running. It's more likely than not the voltage has to be adjusted. In this case, we already had this running with the bad engine, and we made the adjustments then, so we shouldn't have to do that again. Yeah, and that's the problem I was worried about. This exhaust, it extends about a 1/2 inch past this mount. So there's a couple options here. I guess first off, where that bolt is on the top where the bracket is, there's another bolt hole behind there. So we can actually move the bracket forward, and that should solve the problem. Now, the bottom bolt for the bracket is going to be a little bit far away now. So we need a spacer. And I think that'll solve this issue. So let's move the bracket, throw a spacer in there, and try this again. And last but not least, we'll get this handle back on. I'm going to leave the tank off for now. We'll test it without the tank, and assuming everything checks out, we'll throw the tank on and call it done. All right, pretty much ready to go here. I did reinstall the tank. It is not plumbed into the engine. Instead, I am using this external tank. Anyway, the plan is to get the engine started. We'll let it warm up. We'll double check the outputs, and then we'll bring on a half load of about 4,000 watts. We'll double check, make sure things are looking good, and then we'll go for the 7,500 watts that this is rated for. That should be just about 31.25 amps. So last time we tested this with the bad engine, the best it could do is about 4,500 watts. So yeah, I'm hoping for a little bit better this time. So we're starting at about 246 volts. THD is about 7%, and the hertz about 63. So let's bring the load on slowly. We'll turn the master on, the fan on, and let's start with 4,000 watts. Looks like we're doing pretty well. 242 volts. 62 hertz, and the THD is at 21.5%. All right, let's see if we can bring this up to the max. We're currently at about 16 amps, so let's bring it up to 6,000 watts. No issue. About 7,000. Getting pretty close to the max of 30 amps. Now we're just over 30 amps. We're at 7,500 watts. And you can see the engine is struggling under this kind of a load. So I'm actually going to back it off a bit so things stabilize. Now we're at 243 volts. 24% THD, and the hertz are at 60.8. So yeah, not too bad. All right, let's push it a little harder. We'll bring it back up to 7,500 watts. You can see the oscillation there in the engine. Let's try 8,000. Nope. Can't do 8,000, but I guess we knew that. It's only rated at 7,500 watts. No issues to report. Started right up. The engine sounds great. So we brought the load up actually to the max of 7,500 watts, and the engine speed held just fine, although it was fluctuating a bit. So it was right at its limit. You know, I did bring it up a little bit more to 8,000 watts just to see what it would do, and the engine speed did slow quite a bit. So yeah, we were out of power at 7,500 watts, which is fine. I mean, this generator is only rated at 7,500 watts, and that is the best that can be expected out of this. Anyway, it was a long path to get here. You know, Jason bought this machine as a good running machine. At least that's what he was told. It only needed the fuel system gone through. He did that only to find out it had a bad power head. So he found a used one, I put it on, and we load tested it only to find that it also had a bad engine. So yeah, this one's a bit of a loser as far as making any money goes. At this point, it's more about cutting your losses. And in this case, I think he's still going to lose out on this deal, but not quite as bad. Anyway, this one, I think we're pretty much done here. It is doing what it should. So I hope this video helps someone. Thanks for watching.